Hello friends, now we will see an example problem for the minimization of DFA with not reachable states, that is states not reachable from the start state, right? That is, for example, if P and Q are two different states, means when we will see the states P and Q are equivalent, means if extending the transition for some string W for the state P and for the state Q leads to either accepting state or to non-accepting state. That is, both leads to either accepting state or both leads to non-accepting state. Then the states P and Q are said to be equivalent or it is said to be an distinguishable pair of state. Right? Now we will see an example. Consider this automaton. It is having some 8 states. Right? First we will check whether all the states are reachable from the start state. Right? Defaultly we will say that the start state is reachable. A is reachable. Next, from A, whether the remaining states are reachable or not. We have to check whether the states are reachable from the start state or not. First, see, from state A, B is reachable by using the input symbol A. From A, B is reachable by using input symbol A. From A, C is also reachable. That is, here from A to B we are having transition. From B to C also we are having transition. So C is also reachable. Next one is D. From C we are having transition to D. So D is also reachable from the start state A. From A the states reachable are B, C and D are reachable. Next C, E. Is reachable from the start state or not, means it is not reachable from the start state because there is no incoming transition. That is, no incoming transition means from A, from B and or from C or from D, there is no incoming transition for the state E. So we will say that the state E is not reachable from the start state A. Right? Likewise, F is also not reachable. See here, from A there is no direct transition to E. From B also no transition. From C and D also there is no transition to the state E. Right? So E is not reachable from the state A. Right? Next thing is F. F is also not reachable. F is having transition from E, but E is itself not reachable from the start state. So F is also not reachable from the start state. G is also not reachable. And H is also not reachable from the start state. H is having transition to the state D, but there is no transition from D to H, incoming transition from this A, B, C, D to this remaining 4 states. So, all these 4 states are not reachable from the start state. Right? In this automaton, the states E, F, G and H are not reachable from the start state A. Right? So, before going to minimization, first we will eliminate all the not reachable states from the start state. After eliminating these 4 not reachable states, the DFA will be like this. Right? Here we eliminated the not reachable states E, F, G and H. Then the automata will be like this. It is having only 4 states. Right? The table filling algorithm for the automaton with 4 states will be like this. Right? Here, in horizontal position, we will include the 3 states, that is from the start state. First 3 states will be included here. And in vertical direction, from the second state to the last state. Right? In order to eliminate the recursive combination or recursive combination of pair of states. Right? Here we will eliminate the last state in horizontal direction. In vertical direction, we will eliminate the first state and consider from the second state. Right? Recursive pair of state combination can be eliminated like this. Right? Next thing is, we will group the states into 2. Initially, we will group the states into 2. That is, one is the set of non-final states and another one is the set of final states. Here, what are the set of non-final states? From this DFA, we have to form the 2 pairs. That is, one is the set of non-final states. What are the set of non-final states? A, B and C. A, B, C. These are set of non-final states. And next one is the set of final states. Here we are having only one final state, that is D. So D comes under the second category, that is a final state. Right? So D is different from, D is distinguishable with A, likewise B and for C also. So for D, D is different from A and D is different from B and D is different from C. So these are distinguishable pairs. A comma D, B comma D and C comma D are distinguishable pairs of states. Right? Next thing is consider the state A. First we will check A and B. First we will check the states A and B. Initially first state is both the states are non-final state. So we will say the states are equivalent. Next we will consider the states for input symbol A and B. What is the state A comma A? What is the transition for the state A comma A? A comma is A to the state B. Like this for B comma A. B comma A is to the state A. Here both the states A and B are non-final states. So no problem. Up to A transition the states are equivalent. Next A comma B, that is to A. B comma B is to C. Right? Both the states A and C are non-final state. Hence the states are said to be equivalent up to the transitions for the symbol A and B. A and B are equivalent. Next consider state C with A and C. Next compare the states A and C. That is A comma A, C comma A, D. Here D is what? D is a final state. So the states A and C are distinguishable. So A and B are said to be equivalent when compared with the transitions for the symbol A and B. But C is different from A. C is different from A. Next thing is, next compare the state B with C. Already we compared B with A. Next we have to compare the states B and C. See here B and C. What is B comma A? That is to the state A. And C comma A is to the state D. D is a final state but A is a non-final state. So B and C are also a distinguishable pair of state. So A comma B is equivalent but C is distinguishable with A and C is also distinguishable with C. Right? So C is distinguishable. C is distinguishable with A and C is distinguishable with B. Distinguishable with A and distinguishable with B. The distinguishable pair of states are marked by using this cross symbol. Right? The squares marked with cross are distinguishable pair of states. Right? Next thing is we have to prove that the states A and B are equivalent or distinguishable by extending the transitions for modulus of W is equal to 2. That is del of A comma. Already we extended the transition for the symbol A and B, that is modulus of W is equal to 1. Right? Up to modulus of W is equal to 1, the states A and B are equivalent. If you are extending the transition for the next level, that is modulus of W is equal to 2. That is del of A comma AA. Likewise del of B comma AA. What is del of A comma A? That is already we know how we will extend the transition. That is del dash of, right, A comma A. That is what is del of A comma A? Del of A comma A is to B. So it is represented as del of B comma A. What is del of B comma A? That is to the state A. It is equal to A. Like this for del of B comma AA. B comma A is to the state A. Again A comma A is to the state B. So it is also equal to B. Both the transition leads to A comma AA equal to A. B comma AA is equal to B. Both the states are non-final state. Hence up to the symbols AA, the states A and B are equivalent. Next we will extend the state AB for the symbol A and B for the symbol AB. Right? Like this, here we extended the states A and B for the input symbol AB and for the input symbol BA. For the input symbol AB, the states leads to A and C. Here both A and C are non-final state. So no problem. Up to this, the states A and B are equivalent. Next we extended for the input symbol BA. For input symbol BA, A leads to a non-final state, that is B. But B leads to a final state D. So the states A and B are distinguishable. Right? That is the states, the pair of states A and B are distinguishable because for the input symbol BA, A leads to a non-final state but B leads to a final state. Hence the states A and B are distinguishable. So in this example, A and B is also distinguishable. There is no equivalent pairs of states. No equivalent pair of states. All the 4 states are distinguishable. Hence the minimized DFA is also having the same 4 states A, B, C and D. This is also the minimized DFA for this particular problem. The final answer will be the same. It is having some 4 states A, B, C and D, and all the transitions are same. Right? Hence here for B, the input symbol with BA, it leads to a final state, but from A it leads to a non-final state. Hence the states are distinguishable. All the 4 states A, B, C and D are distinguishable pair of states. Right? There is no equivalent states. Yes, thank you.